Hi everyone, welcome into this React Native Heroes warm-up. I'm Mirko, I will be your host for this afternoon. I'm really excited to be here. This is the first edition of React Native Heroes, and I hope to see you as well this Friday to the main event. Today we have got an amazing talk about CodePush. I'm sure that you are as excited as I am. And it is made by Rocco, Luigi, Scarcella, who is joining us. Yes.
Hi, everyone.
Hi, Rocco. How are you?
Fine. Really excited.
Nice. I am really excited for your talk. I'm looking forward for it. I'm coming with a clean slate. I've never used CodePush before, so I hope that I will be able to grasp as much as I can for it. And before rolling out the intro, just a quick reminder for you all, guys, there will be a small Q&A section. So feel free to take note of your questions, and then in the end, you'll be able to have all of your answers from Rocco himself. So let's roll out the intro, and then Rocco will start the talk.
Thank you. Okay. As Mirko said, my name is Rocco. I am head of mobile team at Wezard, and today I will talk about React Native over updates for React Native. React Native is a fantastic tool that allows us to speed up the development time of an application for different operating systems like iOS and Android. However, when we finish the development and it's time to release the product, we have to fight with stores. And what we are going to see today are the problems with standard stores, what is an over-the-air update, and what is CodePush, how it works, its limitations, setup, and use cases. In the web context, we are used to do a deployment, wait for a few minutes, and have the result of our work on live right away. React Native apps are composed of JavaScript files and any associated images, which are bundled together by the packager and distributed as part of a platform-specific binary. When the app is released, updating either the JavaScript file, the JavaScript code, for example, for fixing bugs or adding new features, or adding new image assets, required to recompile the binary for each platform, upload binaries to the App Stores and Google Play Stores and even other stores, and later wait even days for the store teams to perform a review of the update, hoping that it will not be rejected because of some hidden point in the policies. And latest, wait for the update to be distributed to all end users. Could be trivial, this part, but it's not sure that an update available on the store is immediately downloaded by the user, because the user may have set automatic downloads only when connected to Wi-Fi networks. While this process is acceptable for when we are doing a first release or the release of a feature that has taken months of development, it is certainly a big problem when we have an urgency do a bug fix. Now, I would like to tell you a story about my early experiences with releases. I was developing a feature for a small Android app, an event app, my first personal app on stores. Before the deployment, I did some testing and found a little bug. I fixed it right away, and in excitement, I recompiled the app without testing again and uploaded it to the store. A few hours later, the update was available, and I downloaded it. Well, panic. Icons in the bottom bar were gone. The application was impossible to use, and I couldn't move inside the app. I could only click on this tile here in the main screen. So I calmed down and started looking for the problem, and obviously, as it always happens, the problem was a single line of code. So I fixed it and sent a new update. But the new review took 2 days to accept. So the application, the bug remains on the store for 2 days, and only later it will be, the bug was available. Obviously, the moral of this story is that testing is a fundamental step of development flow. But in my opinion, it's also a very good example of how release time are also highly dependent on the stores and on the review process. This is something that we can control. This is a big problem when you are in a hurry for a bug fixing, for example. So we need a faster way to release updates. So we have over-the-air updates. This concept comes from the world of embedded system, where it can be very advantageous to do a firmware update through a wireless network rather than a wired connection. In mobile context, we use this term to indicate an update that does not go through a standard store, App Store, Google Play Store. In this sense, React Native is over-the-air update really. We have a bundle that contains all our JavaScript code and image assets, and we have only to update that. But the platform doesn't have a built-in mechanism to do that. So we use a third-party service that is CodePush. It is a Microsoft App Center cloud service that enables React Native developers to deploy mobile app update directly to their user services, users' devices. It works by acting as a central repository that developers can publish certain update to, and apps can query for update from. This allows you to have direct engagement with your end users while addressing bugs or adding small features that don't require to rebuild a binary and redistributing the binary through the app stores. But let's check for a moment the deployment process to the stores. You have a local repository where you develop your code. Here, you have the JavaScript code and then the native code, the Android native code and the iOS native code. Then, when you want to go ahead and deploy it over an app store, JavaScript code and native code are bundled together, and they are deployed to each store. Here, you have to wait for the review process, and then the app is available on the store. Once the app is on the store, users can download it and use it. But what changed adding CodePush? The App Store deployment process is still there, but the app, the bundled app, has a little bit of extra code that it's going to looking for something from another server. What is this server? Let's say you want to deploy an update for after a bug fix. Now you, from your local code repository, you have to push only the JavaScript code with a deployment key to the Microsoft CodePush server. This server is going to house your JavaScript code depending on whatever key you pass in different code repository. In this server, we could have different variants for the same bundle, and each variant is identified by a key. The JavaScript code you initially deployed on the store, it also references a deployment key. Then, when the user starts the app, what is going to happen is that CodePush code is going to check if there is a new update in the CodePush server. If an update is available, then the device will silently install it in the background while the user is using the app. Then, at the next start, the users will see the new update installed. Now, some bad things. Any change that involve the network code, for example, modifying the app delegate or the main activity file, or adding a new library, cannot be distributed to CodePush and must be updated through the relevant store. In particular, you can add a new library only if it only contains JavaScript code. If it has a native module, you have to pass through Apple and Google Store. When regarding the assets, if you're using the React Native asset system, like the require syntax, you can use this component and these props that have support for their referenced images and videos to update there with CodePush. Another possible problem is store compliance. Google and Apple have corresponding guidelines that have rules you should be aware of before integrating the CodePush solution. In particular, Google described that updating source code by any method or the Google Play update mechanism is restricted. But this restriction does not apply to updated JavaScript bundles, because it says here that the restriction does not apply to code that runs in a virtual machine or an interpreter. And CodePush updates only JavaScript bundle and can't update native code part. Meanwhile, Apple license fully allows performing over-the-air updates so long it doesn't change the primary purpose of the application. And it cannot bypass signing, sandbox, or other security features of the iOS operating system. So CodePush allows you to follow these rules so long as the update you push does not significantly deviate your product from the original application approved by the App Store. There are some cases where the stores removed some apps because they made heavy use of CodePush, but they are very rare. To sum up, the CodePush does not violate the store policies, but you don't have to abuse it. Now we can see some setup of CodePush. First of all, you have to create an App Center account on appcenter.ms website. Then you have to create an app selecting the operating system and the platform, in our case, React Native. It is important to note that you have to select the operating system because you have to create an app for each OS. So 2 apps, one for Android and one for iOS. After do that, you have to initialize CodePush, creating standard deployments. Now we can add the CodePush library to our app, adding the npm package. For simplicity, I show you only Android setup. That is, I think, is more tricky than iOS one. First of all, we have to add these 2 lines to the settings Gradle to tell the app where to find the CodePush module. Then you have to tell your build Gradle to execute the CodePush Gradle at build time. So you have to add this line in the happy Gradle file after the React Gradle line. Then you have to update the main application, the Android main application file, overriding the get.js or bundle file to let CodePush know at runtime time, determine where to get the bundle location from each app start. And latest, to let CodePush runtime know which deployment it should query for updates, in the strings XML file, you have to add the CodePush deployment key. This value is the key of the deployment you want to configure this app against. To get the key, you will have to use the App Center CLI. Once you install it and authenticated to the App Center, you have to you can list all deployment lists with the deployment list command. Once did that, you can copy your key and paste in the strings XML file. Now you just need to wrap your entire app, your root component, with the CodePush iCorner component. By default, CodePush will check for updates on every app start. If an update is available, it will be silently downloaded and installed the next time the app is restarted, which ensure the least invasive experience for the end user. But if you tag an update as mandatory, then it will be installed immediately, ensuring that the user get it as soon as possible. But we can pass a CodePush option object where we can specify other options on how CodePush should work. For example, here, I want to check for new update on every app resume and install it immediately. And I want to show a dialog to check for a confirmation by the user. Here we have all the options we can specify. In particular, the check frequencies could have 3 options. On app start, which is the default one. On app resume, but as I said, indicates you want to check for updates whenever the app is brought back to the foreground. And the third one is manual, that disable automatic checking for updates. Another important option is install mode. This specify when you want to install option updates. The default is on next start. That means that the user will see the new update the next time he opens the app. Another option is on next resume, that indicates you want to install the update, but you don't want to restart the app until the next time the end user resume it. Or immediate, that is the default one for mandatory updates. This indicates that you want to install the update and restart the app immediately. This value is not appropriate for a production environment because it's too invasive of the user experience. The last option, update dialog, is an object used to determine whether a confirmation dialog should be displayed to the end user. Setting this to any true value will enable the dialog with the default string, but you can customize the string. Anyway, the CodePush team recommends to not using it on iOS because among Apple's policies, it is not seen as good to show many dialogues to request review, and even though this dialog is not about a review in the App Store, the policies are a bit ambiguous and about dialogues being shown without user interaction. Obviously, these changes affect the native part. We will have to do a standard update through the store, uploading the binary. Once this update is done, our application will be CodePush ready. In the moment when we need to publish an update after a bug fix, we will only need to upload the JavaScript bundle to the CodePush server with the React release command. In its most basic form, this command requires only one parameter, the owner name, that is the name of the account holder, and the app name. For example, we can see here that we have the owner name and the app name. This command have a simple workflow because it provides many default options. But you can customize all these options. For example, if you want to roll out the update to 100% users, only to a partial. Also, the CodePush client supports differential updates. So even to you're releasing your JavaScript bundle and asset on every update, your end users will only download the files that they need. And the service handles this process automatically. However, it is very likely to have multiple custom builds in our projects, dedicated, for example, to development, QA, or production. This is why it is not a good idea to use a specific key, as I shown earlier in the strings XML file. It's better to specify different keys for each build. And on Android, you can do this editing the build type section under the app with Gradle file, specifying a key for the staging release, a key for the production release, and you should specify a key for the debug because you don't want to download a CodePush update during debug, but you must supply a key, an empty key. By default, when we create an application and initialize CodePush in the App Center dashboard, CodePush generates 2 deployments, one for staging and one for production. But we can generate new deployments, new custom deployments with the deployment add command. Anyway, this kind of flow I described is quite static because we have to maintain a key in the bundled app, in the Gradle file, in the info list file, or in the strings XML file. When we want to have more dynamic way to check for an update, we can query for a CodePush update using the CodePush sync method, in which we specify a CodePush deployment key. And we can pass an option field that is the same of the object I described before. But how we should choose the right deployment key in a dynamic way? We can have 2 possible ways. We can export a user visible mechanism for changing deployments at any time. For example, in your settings page could have a toggle for enabling beta access. In this way, your user can manually choose to download the beta version of the app or the stable version of the app. But this solution puts the decision in the hands of the end users. Otherwise, you can annotate in the server-side profile of the users an additional piece of metadata that indicates the deployment they should sync with. By default, your app could use the binary embedded key, but after the users have authenticated, your server can choose to redirect them to a different deployment. And server side, you can decide if a user should download the version A of your app or the B version. And this solution is perfect for A/B testing. That's it.
Nice. Thank you, Rocco. This was an amazing talk. I really enjoyed it. And I really love the SpongeBob team transitions that you did at the start of the presentation. And I've got a couple of questions myself. If I can just take them, that I wrote them down. All right, yeah. The first one is, did it ever happen to you to receive, I don't know, some complaints from both Google and Apple themselves for any usage of CodePush so far in your apps?
Not in my experience. I only found some issues on CodePush repository on GitHub of people asking for help with the store when the store removed the data app, but they never specify what they update for the reason or the store used to remove the app. So I don't have a specific example of that.
All right. Then let's hope that no app will be down from them in the future. And the last one that I've got is, do you suggest to use CodePush mainly for business logic? And this question is linked to the first one, just to avoid any misunderstanding with Google and Apple themselves, like updating, for example, rendering stuff, filtering, mapping, the business logic itself, with that.
I think updating business logic should not have any issues by the store, because it's not easily visible.
Okay.
But updating the UI may occur in some compliance by the store, especially iOS store, because they pay more attention if there is a button, if you're adding a button or not. So on iOS store, I suggest to do less UI updates.
Okay, then updating buttons on the fly by a condition can be a little bit tricky to do so with app. All right then. Okay. I don't know if anyone has got any question, but I've said them all for myself. And I guess that that's it, guys. I've really enjoyed this talk, Rocco. I want to say thank you again, and remind you all, guys, that this Friday there will be the main event of React Native. So I hope to see you there. And with that, I guess let's roll out the outro and have a nice day.
Goodbye, everyone.